To the first session of the afternoon, which is going to be looking at some novel applications in sports analytics. I have the great pleasure of introducing three wonderful speakers for your enjoyment. So the first one is Brian Macdonald. He's entering his fourth season as the Florida Panthers Director of Hockey Analytics, where he is responsible for analyzing data in both hockey operations and business operations. He previously spent 6 years as an assistant associate professor in the Department of Mathematical Sciences at West Point. He received a Bachelor of Science in Electrical Engineering from Lafayette College in Eastern Pennsylvania, and a Master of Arts and a PhD in Mathematics from Johns Hopkins University. He's also an adjunct professor at Florida Atlantic University, so big welcome for Brian.
Thank you, Andrew, and thanks to the organizers for letting me speak here. It's going to be a little bit of a different talk. Maybe it's more of a business data analysis talk than a sports data analysis talk. But we do use sports and business and sports business data in the model. So, and I also think it's pretty interesting to sports fans. We're talking about attendance at NHL games, and I actually think it's an interesting problem for sports fans, so this is kind of why I offered or submitted to give the talk here. I should also mention this is sort of joint work with Mike Peterson from the Tampa Bay Lightning, who I'm not sure if he's here. Are you here, Mike? I haven't seen him yet. And then also James Sifu, who's also with the Panthers. So of course, you know, usually when you're working on sports data, you don't collaborate with other teams because there's sort of like you have good reasons not to collaborate with other teams. But for business data, I've talked with Mike Peterson on about a few different projects, and this is one of those projects. So, and they've done a very similar model to what we've done with the Panthers with their own internal data. And so what we're going to be talking about today is we want to develop a model where we predict attendance for NHL regular season games using only information that's known before tickets go on sale. So of course, once tickets go on sale, you can get like ticket sales trends. But we want to use only information that is known before tickets go on sale because of the reason that we want to build the model. So the reason we want to build the model is that it can help us answer questions like what games should we put in what tiers as far as single game pricing. So as you might know, the ticket prices for games are not the same for every game. So for us, for example, Tuesday night in October against, I don't want to pick on anyone in particular, but Ottawa is not as good as a December game against Montreal between Christmas and New Year's. That's always by far our best-selling game, and it's just way different than a Tuesday night game in October. And so games are put into tiers typically. Typically teams have 2 to 5 tiers or something like that, or maybe more. And so this would help us answer questions like which games should go in which tiers, because we might have a prediction of what the attendance would be, what the demand for that game would be. Another thing we might want to use this for is what kinds of things do we want to request from the league as they're developing the schedule. So we can't demand that they do anything, but we can make certain requests. And so what are the kinds of things that we want to request? And one specific question that our leadership wanted to address was, do we want to so Saturdays are typically a good day for a game. It's the best day for a game. Do we want to stack the good teams on Saturdays and the weaker drawing opponents, put them in the weekdays, or do we want to kind of balance it out? Do we want to put a strong opponents on a Tuesday in October and then weaker opponents on Saturdays because we know Saturdays do well, no matter what? So that was one specific question that they wanted us to look at. And the same kind of thing for Thanksgiving week. Do we want big teams Thanksgiving week or Christmas week, or do we want to have weaker opponents there and save our bigger games for some other time? So first thing we might do if we know nothing about the problem, which in the beginning I didn't, the first thing we might do is just plot some data. So this is one of the plots that I made very early on. And so what I did was I took attendance, which is published on NHL.com for every game. And I should note that this is announced attendance. So it's not like true number of people in the building. It's not true tickets sold, because what teams typically do is they'll have the number of tickets sold for a game, whether or not they show up, the number of comp tickets handed out for a game, and whether or not they show up, and add those two together, and that's announced attendance. And then some teams will just add some random number greater than 0, which of course we would never do that. So announced attendance isn't perfect, but the reason we wanted to, well, there's a lot of different reasons that we wanted to use this publicly available data. One of the reasons is we didn't have reliable data for ourselves. When I first did this, I think we had 1 season of reliable data, and we just thought that wouldn't be enough to successfully address the problem and model attendance using all of the predictors that we wanted to use. So that was one reason, and well, that was probably like the biggest reason actually. So let's plot the data. And so this is kind of a huge mess, but so let's, for now, just temporarily, let's take our snipping tool and just snip this bottom part and make it bigger, and then talk about it. And so what we have, just to describe what's going on, is along here we have date, and these are kind of off-centered for some reason, but that's 2008, 2010, January 1st, 2010, and so on. This is announced attendance, and each dot here represents a home game for the team listed here. So this dot right here is sometime right before the turn of the year, January 1st, 2010, probably in December or something. And it looks like announced attendance there was maybe 14,000. And so we've done this for all 30 teams in the league and made plots like this for all 30 teams in the league. And I really like this visualization. I was also learning ggplot at the time and facet grid, so I was very happy that I successfully used those two things. But I was also happy because I feel like I learned a lot about the data by making this plot. Just making this simple plot. All we did was plot attendance over time for all 30 teams. So since I miss being a teacher and miss interactive classroom discussions, I'm going to turn this into an interactive portion of the presentation. And I'm going to ask you guys, what can you learn from this visualization? Yeah?
Maxes change by year.
Maxes change by year? Okay, so I guess like right here and right here.
2014 is missing somehow.
Where's that?
So the New York Rangers I was looking at, the max
Oh.
is not the same that
Yeah, you know, any idea why that is? Anyone from New York? So they were doing renovations on MSG that year, so the capacity went down slightly for temporarily. What else? Variability changes over time, so you're probably talking about St. Louis here. A little bit of variable here, not variable at all there. And then it changes after that. Okay. Yeah.
The Rangers always announce that they sold out their games.
Yeah. That's a key point, I guess. They always announce that they sold out their games, but they probably do actually sell out. The building might not look full, but they probably do have a sellout basically every game. Yeah, so some teams have just constant sellouts, which, you know, maybe they're not very interesting to study, or maybe we wouldn't want to include them in the model or something because they provide us no information about what kinds of things affect attendance. What else? Yeah.
The Islanders either have a smaller stadium or they rarely reach capacity.
Okay. Smaller stadium or rarely reach capacity, and this whole time they were in Nassau Coliseum, which I believe was a smaller stadium. Their first year in Brooklyn was, I think it was this year. if I'm not mistaken. Although, oh no, it must be this year, because it looks like it dips down a little bit there, so it must have been the 15-16 season. Okay, anything else? Yeah.
Would percent full be better than actual?
That's a good question. It might be. We haven't tried it yet, but it might be. Yeah. Yeah. Any ideas what those could be? Okay. Yeah, so his guess was blizzard. And it actually was a blizzard. And so one of the things that I actually did was, I mean, I saw those. I didn't throw them out initially. I saw those, built the model, and at the end just checked which my worst predictions were. And I noticed two of the worst predictions, like number 2 and number 3, were both on the same day, both in the New York area. And I figured that probably wouldn't be a coincidence. So it was the Islanders and I think Jersey had home games the same day that had very low attendance compared to what the prediction would be. So I Googled the date and it said blizzard of whatever, 2010 or something. So then I realized that like 6 out of the top, 6 out of the 7 worst predictions were all blizzards. So I just decided to throw out blizzards. I figured that was legit to just throw out those outliers. And then I realized that there were European games. There's for a while the NHL was opening the season with games in Europe, and we threw those out also because we're interested in attendance in North American games. Those are kind of different situations, which you would probably expect to sell out no matter what is going on, since it's like a rare thing to have an NHL game in Europe. So, yeah.
Why would you throw out things due to weather? Wouldn't that be a predictor of maybe why people would go to a game?
Yeah, we could have included it, but I kind of just didn't want to bother with it. So maybe it was laziness, I don't know. But yeah.
Well, didn't you start by saying you were interested in things that were known at the time the schedule was made?
Correct. That would be another reason. Yeah, thank you for coming up with a better answer than mine. Yeah. So we want to only, we don't think we can predict blizzards in January on game days, so we didn't want to include stuff like that. Yeah, we won't have any in Florida either. So it's, anything else we learned from this? Yeah.
Something changed in Tampa Bay around 2012.
Yeah. What do you think? What do you think changed there?
Stamkos came in, Stanley Cup run.
Yeah, they were in the final, or they were in the conference finals, or the finals. I think it was the conference finals. And then they've been a serious contender since then, and that clearly shows. So this is, hope for small market teams that if you build a consistent winner, you will actually draw more fans. Anything else? Yeah, why do you think the data's left skewed? Okay. That's true. Okay. Yeah. I thought maybe at first you meant you noticed that earlier on in the year, to the left of each season. By the way, each color is a season. The gap between them is the summer. I didn't mention that, but maybe that was clear. But early on in the season, there's lower attendance. So it's kind of hard to tell with some of these, but it kind of looks like some of these are slanted upwards a little bit. Earlier on in the season, in October, no one really cares. At the end of the season in April, lots of people care. Anything else? So I think we should probably move on because talk is now half over, and we spent all of it on this slide. But let's go to here's the bigger picture. Some of the trends some of the things that we observed with the smaller one kind of are true here. I'll just point out Nashville, who's been building a contender slowly over the last 10 years. Their attendance is slowly going up, and we saw that with Tampa Bay. We can see it with some other teams. You see how winning even in Boston, back here they weren't that good, but then they were a perennial contender for a while. Chicago, same thing kind of happened. Washington, same thing kind of happened. Anyone know what this is all about? This is Atlanta, and then they went to Winnipeg, and they have a constant sellout. But we see lots of teams with basically constant sellouts, and we see other teams that have variable attendance. So let's move on. So we kind of said this already. For many teams, attendance is relatively flat. Winning definitely matters. So for our model, we actually only wanted to look at other small market teams. So we can sort of justify removing the flat line teams because none of them are small market teams. If we went through and listed them all, these are all small market teams. So we want to look at teams with similar situations as what we have. And so I think we were left with 13 teams. We removed the European games and blizzards. We used several predictive variables. We'll talk about those in the next slide, all of which are known in the summer when we have to decide different ticket price. We have to make different ticket price decisions. And announced attendance is our outcome that we're using, which, as we mentioned, is imperfect because it's not exactly tickets sold or people in the building. It also ignores price, which if you change price, you will change attendance. So it's imperfect for that reason also. But it's decent as a proxy. If we assume that people price reasonably, then it's decent as a proxy for the demand for a game. And so predictors that we used, we've talked about some of these before, but the home team and the away team both matter. We thought would both matter for a game, for attendance. If you're in a more popular place or if you're an original six team, you're going to draw more fans. Day of the week, month of the year, we talked about Saturday versus Tuesday. We talked about October versus April. Different holidays we wanted to use because we specifically wanted to target Thanksgiving and Christmas, but then we just threw in a bunch of other holidays also because why not? Season opener, whether or not it was a season opener, that should have some sort of impact. Whether you're division rival, conference rival, how good you were the previous year, how good you are in the current year, because team performance should matter. And then we threw in some interaction terms as well. So day-month interaction. The reason we threw this in is because we wanted to see if Sundays in the fall were any different than Sundays in the spring because of football. So do we want to just completely avoid Sundays in the fall? Home team and day interaction. We thought maybe different markets would have different preferences as far as day of the week. That they would go to a game. Somebody mentioned to me, like, such and such city, they think date night is Friday night, not Saturday night. So maybe there's higher attendance Friday night. And then home team and month interaction. We wanted to do this, and I think Tampa did this also, because we have a much higher population in the winter months than we do in early fall, early spring months. So November to March, there's much higher population. I might have said attendance. There's a much higher population in South Florida because of all the snowbirds that come down. So we did a home team and month interaction for that. And so the model that we used was a linear model. It was a mixed model. We have a bunch of categorical variables that have 30 categories. And so mixed model seemed best. And the results of the model, the coefficients, or the impact that each of these things has on attendance, independent of all the other variables. I don't think I have to go into that part. So let's get to some of the results, some of the not surprising results. So here's day of the week. So Monday, on average, you expect 700 less people on average than a typical game. And on a Saturday, you would expect 1,000 people on average. More than a typical game. And it's probably expected. Friday and Saturday are the biggest nights, followed by Sunday and Thursday, and then Monday, Tuesday, Wednesday are all bad. So it's probably not too surprising. But it's stuff that we already knew, but at least we've come up with a way to quantify all these things. And we're quantifying them all at the same time as we're quantifying the effects of other variables. So here's the effect of month on attendance. So all other things being equal, if you have a game in October, That's about 2,000 different than having a game in April. 2,000 people different on average. And attendance, it's monotonically increasing. I haven't used that word in a while. I don't use that around the office a whole lot, but attendance it looks like it's monotonically increasing, over time throughout the season. So here's an interesting one. Here's away team. So I thought this was kind of interesting because if we look at the top here, 6 of the top 7 teams are original 6 teams. We got Detroit, the Rangers. Pittsburgh's not original 6. They're the exception. Boston, Chicago, Montreal, and Toronto. Pittsburgh was the exception, but they have Crosby. They've won a couple cups. So they're an exception. The next 2 teams, Philly and Washington, 2 pretty popular teams because of Ovechkin, and then Philly because of a lot of different reasons. And then, down here is a lot of the new expansion teams, which their franchises aren't as old, so they don't have as much of a fan base outside of their own region. But, over time, as people move around the country all the time, they'll probably they'll build up their fan base. But interesting, the 2 Florida teams are in the middle here. I was a little surprised. I actually expected, since we're sort of newer, that we'd be closer to the bottom. But so let's move on to holidays. This is my other favorite one. So the thing that we looked at around Christmas time, it's not just us that sees a huge bump in attendance over Christmas. It's everyone. We did it by day too, and so there's over 2,000 people more than you would typically have in a normal game just by being near Christmas and New Year's. And there's a couple other interesting results here. I thought, like, season opener is a really big thing. President's Day is huge, and then Thanksgiving week is big. Not as big as Christmas week, but Thanksgiving week you see a bump in attendance. And there's some holidays there that where you see negative, which is one of them being Halloween, one of them being Easter. It's because people already have things planned on those days, whether it be trick-or-treating or going out downtown and getting drunk if you're in your 20s. Or for Easter, people have either church or Easter brunch in the afternoon or something like that. So games are less in demand during those times. And what else? I guess that's most of the interesting results there. We also checked the day before Monday holiday games, the day before holiday games. There was a slight bump in those. None of the Jewish holidays, none of the big ones other than Hanukkah overlap with the regular season. They're in the preseason. The 2 recent ones that we have now, they're all in the preseason games. So we didn't include those, but include a lot of different holidays there. So, all right. Day, month combinations. We found some very small effects, almost negligible, but this looks like a garbage for the most part, except down here. This is Sunday, October, Sunday, November, Sunday, December, and so on. So it does look like there's a little bit less in demand in the fall for a Sunday game than there is in the spring. But the effects are small. I think there's a lot of shrinkage going on here because there's not a lot of data for each possibility. Something like that. Other things that we looked at: do we want a good team on a Saturday and a bad team on a Tuesday, or the other way around? And we found nothing. Basically, we found no evidence that that's better in terms of attendance. However, in terms of revenue, it's much better to stack the best teams on the best days. We found record matters for the home and away team, both this year and last year. So there's a bit of a lag in terms of the popularity of teams. I guess you could call it sort of a lag. And so let's just show some results for when we actually use this model to tier our games. So here along the bottom, I changed the I arbitrarily changed the scale of the axes so that I wasn't revealing actual revenue numbers to you because I figured, I don't know, probably not supposed to do that. But it doesn't matter. It's just a linear scale, so the picture looks exactly the same. Just the axes are different. So, but along here, you see groups of games right here. This year, we for our budgeting purposes, we chose, I think it was about 10 tiers of games. And we just grouped them together here, and we had revenue projections for each of them. And then, so that's along this axis. Along this axis was actual revenue for these games. And so, we kind of see, so the blue dots along here are the average for each tier. And then the blue line is just connecting all those dots. So the good thing that we see is that the blue line basically goes up. In other words, if we put a game in a higher tier, then on average, they will have higher revenue. It's not exactly true for every game. We kind of missed, we had this one in a lower tier than that one, but it's pretty close. We did pretty close to doing a decent job, especially considering we didn't use any ticket sales data. We did this in July when the schedule came out. All of the variables that we just talked about were available in July. So after the NHL schedule comes out. So I think we did a pretty decent job, considering what information we used. And the outliers are all understandable, actually. So this one we actually didn't listen to the model, and we bumped it up a couple tiers because someone in the organization was like, well, in my previous organization, that was a Good Friday game, a Black Friday game, I'm sorry, day after Thanksgiving game. Attendance at his previous team was always super huge on Black Friday. So we just made the decision to bump it up a couple tiers. Turns out that wasn't a good idea because this way underperformed what we had expected based on what tier it was in. This game, this was an unusual game because that was the season that Carey Price got injured in December, and Montreal was not very good for the second half of the year there, so that kind of decreased the demand for that game. And also, we had, so we're ignoring Price right now. We haven't really said anything about Price, but we also know that we priced that game way too high, so that had the effect of decreasing attendance also. And then this was, we were battling for them for a playoff spot. This was a Saturday game in March where we were next to each other in the standings. It was probably the biggest regular season game of the year to that point, and that had way higher attendance than we expected in the summer because of circumstances that we couldn't necessarily predict. So you could actually use more hockey data to predict how good teams will be, predict what their record will be at certain points of the season. Well, we haven't done that yet, and we might not because I don't know if there's much incentive of getting much more accurate here, but. And then this is what we did for last year. We had 43 different budgets instead of 10 different budgets, and this is this is just, again, budget versus actual with the real numbers hidden because of a linear transformation. And so I'm almost out of time, but one thing that you could do is use this model in conjunction with internal data, where we now have 3 seasons of internal data, so we can actually use that to do some reasonable things. So combine those two and then average them and that's what we did for this year for the upcoming 17-18 season. And we get something like this, and I've hid the actual games here in case there are any secondary ticket brokers in here trying to steal information. But this is the Montreal game, I'll tell you that one. It's a big outlier for us. And we just kind of plotted the average, and then these bars are indicating one model versus the other model. So, and I think I have to pretty much finish. So we'll skip this stuff, and we'll end there. Thank you.